Hello everyone. Today we are going to be talking about mathematically adding vectors. So to start, our objectives for today are to be able to add vectors using a mathematical model. So here we have a triangle, and what it's doing is it is breaking up, it's two vectors, and we're adding them together, tip of one to the tail of the other. It's 12 meters to the east and then 12 meters north. So the way to do this that you're used to is to add these together graphically, so tip to tail, and then take a ruler and make a scaled drawing and then just measure it and use the scale to find it. Now, as some of you have figured out, you can actually do this and solve for c right here using Pythagorean's theorem, c squared equals a squared plus b squared, and solve for c. So then c is equal to the square root of 12 squared plus 12 squared, and you get 16.97 meters. And then you want to also solve for this angle here, theta. And to do that, you get, it's this one here, 12 is across from the theta, so it's opposite. And then this one here is next to this theta, so it's adjacent. So then we have opposite over adjacent is equal to tangent. So then we have tangent of theta is equal to 12 over 12. And we're looking for theta, so to get theta by itself, you have to put tan to the minus 1, inverse tangent, on both sides. So then it's inverse tangent of 1, and that's 45 degrees. Okay, so what could we do to make it so that we could use this same kind of technique in order to solve it for pretty much any vector, any set of vectors that we want to add together? So that's our goal for today. So to do that, this is the example problem that I want to show you. So we want to go from here to here. This is the resultant of taking 8 meters east and then 12 meters 30 degrees north of east. So this needs an arrowhead. It will end up this way. Well, there's two arrowheads. It's just hard to see. But to do this, what we're going to do is we're going to create another triangle, a couple of triangles actually. So first, what we want to do is we want to add these together, and we want to add the x component, so the x part, and the y component, or the y part, of all of the vectors. So let's start with the easy one. What would the x part be of the 8 meters east? So if we put it in xy form, we can actually see it in a point. So the x part here would just be 8, and the y would be 0. So we can put that there and keep it there for a little bit. Now for this vector here, the 12 meters 30 degrees north of east, we can break it up into x and y components, or x and y parts. You can see that there's this part here and then this part here. So now we can find this y and we can find this x. To do that, we still use SOHCAHTOA. And we're going to solve for x and we're going to solve for y. So first, it's going to be the y. So this is 30 degrees. So y is opposite. The 12 right here is the hypotenuse. So we have opposite over hypotenuse. There should be an O. This is equal to sine. So then we have sine of 30 is equal to y over 12. Then we can solve for y, and we get y is equal to 12 sine 30. When we plug this into our calculator, we get 6 meters. This is 6. And we can put that on the y side because it's the y part of this one. And we want to add all the y's and we want to add all the x's together. So then the x right here, this is the next one. X is going to be the same kind of thing, but this is adjacent because it is next to this angle. So it's adjacent over hypotenuse. And so we get cosine of 30 is equal to x over 12. And so we get 12 cosine of 30. And that we get to be 10.39 meters. And it can go over here on the x part, okay? So now you can see that when we add it all together, that the x's were 8 meters and 10.39 meters, and we add them together and we get 18.39 or 18.4 meters. And the y part we add together, and that is equal to 6 meters. So then we can put these together. So we're creating a new triangle. This is 18.39. This is 6. And then like that. We're looking for C right here and this angle right there. To do that, it's going to be opposite over adjacent. So that's tangent in order to get this angle right here. So we can say inverse of tangent of 6 over 18.39. And that gives us the 18.1 degrees right here. And then the C, that's your normal Pythagorean theorem. So we get C equals 18.39 squared plus 6 squared. And you end up with 19.35 meters. So that's how you do these types of problems. Here is the next set of practice problems. So I'm going to label these 1, 2, and 3. And I want you to work on figuring out what the resultant of each of these is, both the resultant in magnitude, so the length, and the direction. So what is the length? And direction. So angle of the resultants. That's what I have for you. Thanks.